Okay. 12.2. Product rule. And you don't need to get caught up with being able to write the rule, but you do need to understand the rule. And it says if f of x is equal to u of x times v of x. In other words, there's two pieces to this that are being multiplied together, both of them having x in them. Then you can't just take the derivative like we did with a plain old polynomial. You have to use the product rule. And the product rule says f prime of x is equal to u of x times v prime of x plus v of x times u prime of x. In plain words, plain old English, it's the first one times the derivative of the second plus the second times the derivative of the first. Order doesn't really matter with products because they're being added, so if you did it backwards, it wouldn't hurt you. When we get to quotients, order will matter. But for these, it doesn't. So let's see what it looks like with an example. All right, we have f of x is equal to 2x plus 3 times 3x squared. Now, granted, you could multiply out 3x squared times those pieces. And for this one, that might be easy. But if you had something to the fifth, something to the sixth, and then another piece, you're not going to be able to do that. So there's a rule. So I like to start out when you're first doing it and write what I call a roadmap. So f prime of x equals the first times, and I write out d dx. That's saying take the derivative of that piece, plus 3x squared times the derivative of the other piece. So that tells me in that first line that I'm only taking the derivative in two places. I'm taking it here, and I'm taking it here. Okay? So 2x plus 3 times, and the derivative of 3x squared is 6x. Plus 3x squared times, what's the derivative of 2x plus 3? It's just 2. So in this line, I've taken the derivatives of the two places I needed. Then it's a matter of multiplying, collecting like terms, that sort of thing. You get 12x squared plus 18x plus 6x squared. These two guys are the same, so it's 18x squared plus 18x. And I can't remember. They may want it factored out. I really couldn't remember when I was doing this one. So you'll be able to see. You could check. Or this was an example, so this wasn't one out of the problem set anyway. Do you get the idea? We're going to work enough of them that the rule will become a lot easier. First one times derivative of the second plus second times derivative of the first. That's what you're going to do. Okay? That's if it's a product. Part of the deal is recognizing when things are products. And I know that sounds easy, but sometimes it's not as evident as it maybe should be. All right, quotient rule. When you've got something that is a quotient and you have a u of x over a v of x. This rule is a little bit more complex, and order matters. If you do the order wrong, you'll get the wrong answer. It is the bottom times the derivative of the top minus the top times the derivative of the bottom. And order matters because you've got that minus there. All over the bottom squared. Lots of u's, lots of v's. Don't get caught up with that. Kind of get it in your head. Say it to yourself. Bottom times the derivative of the top minus the top times the derivative of the bottom. Okay, all over the bottom squared. So I have one example of that. You have something like 2x minus 1 over 4x plus 3. That's a quotient. So we're going to use the quotient rule. All right? The bottom, 4x plus 3 times the derivative of the top minus, and put that stuff in brackets. If you don't, you're going to make a sign error because it's minusing the whole thing. And that can get a little bit complex. You don't want to miss a sign. So it's 2x minus 1 times the derivative of 4x plus 3 all over 4x plus 3 squared. So derivative of 2x minus 1 is 2, right there. Derivative of 4x plus 3 is 4, right there. Okay? And I multiplied in here. 4 times 2x is 8x minus 4. But because I had that bracket there, I know I'm subtracting both of those pieces. So the signs are going to change. So I end up with 8x minus 8x. So those x's go away, and I just have 10 on the top over 4x plus 3 squared. Most often, they do not want you to go ahead and square that bottom part out. The answer, okay, and don't show me again. Thank you for reminding me. Okay, it's never done that. I've had this, months, never done that. All right, so leave it as 10 over 4x plus 3 squared. If it's something different, I'll try to let you know when we work on the problems. Okay. Actually, I think this is, look, no, it's not. Okay. All right, any questions? Not a rule that you're going to have down maybe the first few problems that you do, but you'll get it. I will tell you on the final, there will be a formula sheet. But try learning them for the first test. We'll see. All right. You good? Yes, sir. And the reason, and I see you just taking it all in, and that's fine with me. I don't have a problem if you're sitting there not writing one thing, as long as you're going to go home and get them. Some people are really auditory learners, and they have a hard time doing this and really paying attention to what's going on. But some people need to write it a couple of times to feel good about it. So I'm trying to meet all those needs. So hopefully that works. Can you scroll that back? Yes, sir. Is that good? Okay. And by the way, if your computer at home is not functioning or whatever, and you want to stay past 12:30, I don't know anybody will, but if you want to, the lab is actually going to be open till I think 7. So anytime you want to do the work here, there's also computers in the library that already have all this loaded, so you could work there, but you can definitely do it at home when you get yourself set up. Okay. Are you good? Can I move up a little? Okay. All right. All right, so first problem. We definitely know that that's a product. So we're going to write y prime is equal to 5x squared plus 2 times the derivative of 4x minus 5 plus 4x minus 5 times the derivative of 5x squared plus 2. If you get comfortable and you don't want to write the roadmap, that's fine. There will be times where it will really be helpful. But if you're good at it and you get to where you're good at it real quickly, then don't fool with that. But it's a good starting place. So I've got to take the derivative here and here. That's the only places I'm taking the derivative. So I have 5x squared plus 2 times, what's the derivative of 4x minus 5? 4. Plus 4x minus 5. What's the derivative of this guy? 10x. Okay. So multiply out. Then you'll collect your like terms for your final answer, and you get not 20, it's 16. Okay. We good? Okay. All right. For number 2, 5x plus 6 squared. You want to think of that as 5x plus 6 times 5x plus 6. And so I did that over here where I kind of went ahead and, I don't know why I wrote that little over there, multiplied those out. That's just using FOIL. Or you can use that shortcut. Anybody ever use the shortcut to square a binomial? What I tell my college algebra kiddos, square that one, and to get the middle term, it's that times 2. And you don't have to write anything out, but I don't know if that works. So when you get this here, take the derivative of it, you get 50x plus 60. Okay. All right. That one's easy. Easy, easy. All right. The next one has some negative exponents. And it's a product. So we're going to use the product rule. Let's write out our roadmap. P prime of y equals y to the negative 1 plus y to the negative 2 times the derivative of this guy. Oh, I'm not going to have room. Nice thing about this is I get to scroll. You may not get to scroll. So there's our roadmap. We should know where we're going to take derivatives right here and right here. Okay. Move up a little bit. Okay, so that's y prime. Red. Where's my red? Okay, what's the derivative of this guy? That's a negative 3. So what's that going to be? Oh, it'd be good to be in red instead of yellow. All right. Y to the negative 1 plus y to the negative 2 times. What's the derivative of this? Negative 12 y to the what? Negative 4 plus 28 y to the what? Negative 5 plus 4y negative 3. That's a minus. Okay, and the derivative of that guy, why is that not working? What's the derivative of this? But isn't it negative y to the negative 2? Yes. Okay. All right, you have to be careful with those signs. And then you've got to multiply. That just looks ugly, doesn't it? Okay. First highlighted? Yeah, it is. It's there, but it's not showing. But I'll make that better for you. Okay, so now you're going to multiply right here. And remembering that when you multiply, you do what with the exponents? Add them. So we've got negative 12 y to the what? Negative 5. That's that one times that one. Minus 12y to the what? Negative 6. Yep. And then we're going to multiply this guy by both those. So we get plus 28y to the negative 6 plus 28y to the negative 7 plus, you guys may already have it done on your paper, negative 4y to the negative 5 plus 7y to the negative 6 minus 8y to the negative 6 plus 14y to the negative 7. Lots of stuff. Lots of stuff. I need a little bit more room. Cool. Okay. All right. Now, if you've got that written, you need to collect like terms. And when you do, you would get negative 16y to the negative 5 plus 15y to the negative 6 plus 42y to the negative 7. So double check me on that, but I believe that that's our answer. To get to see it all, let's see, I don't know if you can see it, but I can make it 75%. And you can see it all at once. Oh, that just looks messy. Okay. Everybody good? Can you see it way back at the back if I make it that little? Not really. You can. Or you already have it. Did anybody check me on the collecting like terms and make sure that I had it right? Don't always assume. All right, let's go back to 100%. All right, let's go to number 4. Number 4 is a quotient, 6x minus 7 over 2x plus 1. Okay, and I really don't know why I was scooted way over. Let's go over here. All right, y prime equals the bottom times, let's just go ahead and do it. What's the derivative of the top? 6 minus the top times the derivative of the bottom, which is 2, all over the bottom squared. So on this one, I did the derivative without writing the road map. I just put that in there. So if I multiply 6 times that, I get 12x plus 6 minus 12x minus 14. Well, I haven't done the minus yet, so inside it's that, but you're right, it will change to that. If you can do it all in one, that's fine. But okay, might need more room here. Okay, so then just collect and do that. So 12x plus 6 minus 12x plus 14 over 2x plus 1 squared. So what does that equal? What happens on the top? Yeah, so we have 20 over 2x plus 1 squared, and that should be the answer. Did somebody just close my door? Were they walking by and they just closed it? Oh, now that's on video. Okay, whatever. Okay, all right. Everybody good on that one? All right. Number 5 is very much like that. You try it. I'll write up here, but you try number 5. Try writing it and seeing what you get. don't know why I picked two that were so much alike. Crazy. Well, sometimes I'm picking problems and I work them afterwards, and then I'm just either too tired or whatever to take them out, so whatever. So those should be easy. You've done a few of them. Okay, questions? Did everybody get that one okay? And I'm so sorry. I really hope that screen's going to be up so that bar is not going to be in your way. All right, number 6. Did I not? Is this what you guys have? Is that right? Okay. All right, so this is a little bit different. Let's work this one. So y prime is x squared plus 7 times the derivative of the top, which is what? 6x minus 3x squared plus 5 times the derivative of the bottom, which is 2x, all over the bottom squared. So we'll just do some multiplying. We have 6x cubed plus 42x minus 6x cubed plus 10x. So what do we end up with? 32x over that. And that is the format that MathLab is going to want. Okay, for some reason number 7. Do you have 7? I didn't work 7. I have the answer for it, and we can work it, but it's just, whoa. I think you can do that one. Do we need to work it? Number 7 is what? 6x squared?
X squared minus 6x.
Oh. Do what?
Number 7.
Okay. Maybe that's why I didn't work it. I didn't have it. Oh, okay. So I don't have the answer to that one. Okay, x squared minus 6x plus 5 over x squared plus 7. Okay. All right, no different. Is this y equals? Okay. So y prime is equal to x squared plus 7 times. Now what's the derivative of that top part? Minus that whole thing times the derivative of the bottom, which is 2x over x squared plus 7 squared. I need much more room. Okay, so go ahead and multiply. So what do we get here? We get 2x cubed plus 14x minus 6x squared minus 42 minus 2x cubed minus 12x squared plus 10x over if you catch me where I've made an error, please feel free to tell me. Okay, so those x cubes are going to go away. I'll just write it one more time. Bless you. Okay. All right, so this guy and that guy go away. How many x squareds do we have? 6. Okay. 6x squared. And how many x's? 4. And just a minus 42. Is that right? Anybody see anything that we could do on the top? You could take out, you could take out 2. That leaves you 3x squared plus 2x minus 21. I don't think it's going to help you much. So I think that's probably where we end up. I don't think so, because it's not going to help you cancel out on the, if it was something on the bottom, we'll come to some where it's definitely what they want you to do. If we find that that's not the case when we get in there, if somebody finds it, let everybody else know that they do want that if you get there first. Okay? All right, this number 8 is, I think I went ahead and worked this one because it's kind of a mess. So, number 8, is the problem written this way? Okay. So, you want to think of it as this, 4x plus 7 over x to the 1/2. You could. Why did I leave that over there? Don't know why I left that over there. Let me just get most of that up there. This is kind of a crazy problem. Let's see. When we get down to, yeah. So all I did was take the derivative and take the derivative there. Now, do you see this one? When you take the derivative of this, of the square root of x, that's x to the 1/2. And when you're taking the derivative of it, it's easier to look at it that way. And that becomes 1/2 x to the negative 1/2. Okay? So I did that there. And then I just multiplied this stuff by this guy. And that gave me what's in here in the parentheses. Over here, I just have 4 square roots of x. And why is it all over x? Yeah, it was the square root of x squared. So that just became x on the bottom. Okay? Do what? Okay, when you do the quotient rule, the bottom, it's like this. That had been the square root of x squared. So it became x. Okay? All right. Now, how did we go from this line to this line? That's what we need to look at. This is 4x to the 1/2, right? And we had a minus 2x to the 1/2. So that left us 2x to the 1/2. So that's subtracting those two guys. Does that make sense? Okay. So we had 2x to the 1/2 minus, because of that minus there, 7/2 x to the 1/2. All of that over x. Okay. From that point, I'm not sure what if I did anything there. Okay. If you separate these, you have 2x to the 1/2 over x minus 7/2 x over x. Can you do that? What happened there? That should be, this is to the negative 1/2. Did that just get erased? Sorry. Does that make sense? That little thing there. Go away. I'm saying, does it make sense? Probably none of it makes sense. All right. What happened from here to here? 2x to the 1/2 over x. How does that become this? When you have a division, you subtract exponents. Just like we said, when you have a multiplication, you add exponents. So there's an understood 1 here, right? So 1/2 minus 1 becomes negative 1/2. 1/2 minus this understood 1. Understood 1. So it became 2x to the negative 1/2 minus 7/2. We had a negative 1/2. We subtracted 1. That gives us negative 3/2. This is algebra coming back to haunt you. Okay? Okay. This 2x to the negative 1/2, I switched to 2 over the square root of x, knowing that that was kind of the way the stuff was at the beginning. And so the answer is going to have to be back in that. So 2 over the square root of x minus 7 over 2 cube root of x. How did I get that? What's that? Not cube root of x, square root of x cubed. I said it wrong. Remember, that's the index. That's there. And cubed is there. The good news is you didn't have to come up with this on your own. And when you go to do the problem on Math Lab, you got this to follow. Okay? Because you might not come up with that on your own. You might, but you might not. If it's been a while and you've slept since algebra. Okay. The square root of x cubed can be simplified. You want to think about, there's a perfect square inside there. X squared times x. So you can take the square root of x squared. So x comes out and you're left with a square root of x. Does that make sense? Okay, because you had square root of x cubed. So we pulled out an x. So we have 2x square root of x. We have square root of x over here. We've got a subtraction. With fractions, we have to have a common denominator. Common denominator is 2x times the square root of x. So I changed this one to 4x over that, and I come up with the answer that Math Lab wants. You probably won't have one like that on the test, I can pretty assure you. But you do have one on the homework. Okay? It's a good problem. It's a lot of algebra. Calculus isn't bad. It's the algebra. Question? Anybody? No. Okay. All right. Do you have one more on there? One more question? Number 9. Number 9. A lot of work on number 9. I know. I'm sorry. I can just hear it. I can just hear it in your voices. Oh, God. This is horrible. All right. The thing you have to recognize is that this is a quotient with the top part of it being a product. So you have to think of it as a quotient first and then a product. So when you write your roadmap, and this is when it is important to write the roadmap, it'll help you. You have the bottom times the derivative of the top minus the top times the derivative of the bottom. Okay, so that's cool. We've got to take the derivative when it's a product, and we need to know that. So those are the two places we're going to take the derivative, what I've got in yellow. And you have to use that rule for finding the derivative of that. And I don't think I wrote out all of that. If you took that over to the side and did the derivative of this, you would have that times the derivative of this plus this times the derivative of that. So maybe work that out on your own. I didn't work that out. Do we need to? Do I need to do that? Liz, you got it, don't you? Right there. Just right here. So do that product rule, and you should get this. You should get 60x squared plus 70x plus 12. Calculators? Yeah. And I have one more.
I just need one.
Oh, you just need one. See if that's working. Sorry. That's all right.
Yeah,
I'm sure
batteries are low.
Take that one. Thank you. It's my sister. She's teaching next door. She's just short. She's a short version. Okay. Did anybody do it and get that? Or everybody didn't do it and didn't get it? Or didn't care? Just wrote down the words that I wrote on the paper? Please tell me someone did it. Akivia, you did it, didn't you? No. It looks right. Always go with that. Looks right. That'll kill you on multiple choice, but yeah. Okay. All right. If it's right, and we're assuming it is, then it's just algebra, multiplying, subtracting, collecting like terms, just a lot of stuff. You are going to have to do it on Math Lab, but I can't quite get over here enough. There. Maybe. Have I pushed it up too far that you're missing something? Or are you good? So it's a lot of algebra. The problem itself is not that bad. It's tedious is what it is. And you do have to remember that you have the quotient, write it out that way. And then when you have to take the derivative of a top or a bottom that happens to be a product, you have to use that product rule. And the final answer is that. So hopefully, does that make sense? You ready to do some problems in the computer? Let's do it. Okay, what I would like, let me know when you're through, because I'm going to pause my recording. We have a few people I know that aren't here, and so those people are going to enjoy the video, I hope. All right, let me, we good?